Hey everyone, and welcome. Are you ready to put your science knowledge to the test? Because today we are diving into two super cool topics: matter and the incredible journey of the water cycle. This is going to be fun. Let's see what you've got. Okay, so the rules are super simple. I'm going to ask a question, you take a second to think of the answer in your head, and then boom, we'll reveal it together. Sound good? Awesome. Let's get into it. All right, kicking things off with round one, all about matter. You know, the stuff that literally makes up everything. All right, first question on the board. Let's start with the basics. What is matter? And the answer is anything that has mass and takes up space. So think about it. That means you, the chair you're sitting on, even the air you're breathing right now. It's all matter. Okay, next up. If everything's made of matter, what is matter itself made of? What are those tiny, tiny building blocks? Get this, it's made of super tiny particles called molecules. And when I say tiny, I mean so small you can't even see them. But put enough of them together and you get, well, everything. Ready for the next one? Okay, we know matter can come in different forms. Can you name the three big ones? The three states of matter? You got it. They are solids, liquids, and gases. Think of an ice cube. That's a solid. The water it melts into, that's a liquid, and the air all around us, that's a gas. Simple. So, what's the special name for when something changes from one state to another? You know, like when that solid ice turns into liquid water? It's simply called a change of state. And this one little idea is a huge deal in science. It explains so much about how the world works. All right, let's get a little more specific. First up, what exactly is melting? Melting, that's when a solid turns into a liquid. It all happens because of heat. The heat gives the tiny molecules enough energy to break loose and start flowing around, just like an ice cube in your lemonade on a hot day. Okay, how about this one? What do we call it when a liquid changes into a gas? That would be evaporation. Again, it's all about heat. The liquid's molecules get so energized they just escape and turn into a gas. It's exactly why a puddle disappears after it stops raining on a sunny day. All right, here comes a tricky one. A lot of people mix these up. What's the real difference between water vapor and steam? Are they the same thing? Okay, so check this out. The biggest difference is that you can't see water vapor. It's an invisible gas. What we call steam, like the puff you see from a kettle, is actually a tiny little cloud of water droplets. It's not a gas anymore. So water vapor is invisible, steam is visible. Pretty cool, right? Okay, let's flip it around. What do we call it when a gas turns back into a liquid? That process is condensation. It's basically the exact opposite of evaporation. This time, instead of heating up, the gas cools down. The molecules lose energy, slow down, and group back together into little droplets. You see this all the time on the outside of a cold drink. Last one for this round, you're doing great. So, what's it called when a liquid turns into a solid? You probably know this one. It's freezing, or the sciencey name is solidification. The liquid gets so cold that its molecules slow way, way down and lock into place, turning it into a solid, just like water turning into ice. Awesome job on round one. Now, all those things we just talked about, melting, evaporation, condensation, they don't just happen in your kitchen. They happen on a massive scale all over the planet, which brings us to round two, the amazing water cycle. So let's start with the big picture. What exactly is the water cycle? The water cycle is basically the journey water takes as it moves all around our planet. It's this constant, never-ending loop of water going up into the sky, across the land, and down into the oceans. It's what keeps our world alive. So, with all this water constantly moving around, evaporating, raining, flowing in rivers, does the total amount of water we have on Earth ever change? Like, do we ever get more or less? Believe it or not, the answer is no. The total amount of water on our planet has pretty much stayed the same for billions of years. It just keeps getting recycled over and over and over again. How amazing is that? Okay, we learned that evaporation needs energy, right? So what provides the massive amount of energy needed to evaporate entire oceans and lakes? It's the sun. The sun's heat is the powerhouse, the engine that drives the whole water cycle. It warms up the water and gives it the kick it needs to start its journey into the atmosphere. All right, we see them all the time, but how do clouds actually form? This might have something to do with a word we learned in round one. It all starts when that invisible water vapor rises up. As it gets higher, the air gets colder. And what happens when water vapor gets cold? Condensation. It turns back into millions of teeny tiny water droplets, and when they all clump together, you get a cloud. And for our final quiz question, what happens when those little water droplets in the cloud get too big and heavy to float anymore? What do we call it when they fall back down to Earth? The answer is precipitation. And depending on how cold it is, that could be rain, snow, or even hail. And with that, the water is back on Earth, ready to start the cycle all over again. Great job! And that's the end of the quiz. You did it. Before we go, let's just quickly recap the biggest ideas we talked about. So, what are the big takeaways? First, remember everything is made of matter, and it comes in 3 states: solid, liquid, and gas. Second, the sun is the powerhouse that drives the whole water cycle. And finally, all the water on Earth is constantly on the move through evaporation, condensation, and precipitation. Got it? Awesome. Okay, I'm going to leave you with a little something to think about. Since the amount of water on Earth never changes, the water in the glass you're drinking right now, where was it 100 years ago? What about 1,000 years ago? Could a dinosaur have once drank that same water? Kind of blows your mind, right? Thanks so much for playing along today, and never stop being curious.